Time for more algebra tiles, but first, why'd the skeleton go to the party alone? Because he had no buddy to go with. Like, no body. Because he's a skeleton. Hilarious. Okay, so before we get started with the algebra tiles, let's review something you probably remember from a couple years ago. If you have a multiplication problem, you can always represent it with a rectangle, with an array. For example, this is 2 times 8, which you know is 16, because there's 16 squares here, 2 groups of 8. But you can also split that up however you like. You could split it right here so that you have 2 times 3. All we're doing is cutting this piece out, which is 6, and 2 times 5, which is 10. And together, that's 16. So this is the distributive property. We can multiply by the contents of this entire length, or we can multiply by these two lengths separately. And the expression would look like this: 2 times 3 plus 5. And if we distribute that 2, multiplying each quantity by it, we're going to get the same value as if we had added this first. Okay. So we want to demonstrate this using algebra tiles, because you need to be able to use the distributive property with all sorts of expressions that look like this and harder. Here's how it works. So this image here represents the array, the multiplication. And what we're going to do is we're going to build each of the quantities on the sides of the array. Let's do this one together as an example. So this is x plus 5 times 2. So x, that's an x, and then plus 5 means I have 5 of these singles. Okay, so that's this way, and then times 2 means I've got 2 going down this way. So this was just like 2 times 8, but now it's 2 times x plus 5. To find the answer, we need to figure out what's inside, and to do that, we just fill in using our tiles. So underneath these x's, we've got 2 x's, because 1x times 2, that makes this area. Oops. Okay, and then underneath the 5 ones, I've got 2 times 5, which without building, you should probably already be thinking of that answer, but I'm going to build it anyways to demonstrate it. We have 2 times 5, or 10. Okay, so what's inside the array, this part inside, that's our answer. That's what we've simplified this to. So this, if we want to rewrite this, combining like terms, is 2x's plus 10. Okay, we're just going to ignore direction 3. We don't need to do that. Let's do another one before you try some more interesting ones on your own. 2 times 2x plus 3. So this is the array, and we're going to build each number, each of these factors on the side. So 2 goes here. So 1, 2. And then 2x plus 3. Remember that 2x means 2 times x, or 2 copies of x. So here's 2 x's, plus 3 means I need to have 3 singles. See if that whole thing will fit. 1, 2, and 3. Okay, and now the simplified version is what's on the inside, so I need to fill this in. Underneath each of these x's, I've got 2 more x's, because 2 times 1, x is 2x. And then 2 times 1 more x is 2 x's. And really what I'm doing is just filling in this rectangle. I'm completing the rectangle. And then over here, I've got 2 times 3, which you're probably already thinking, I know it's 6, which is great. Okay. And once we've got that, the solution, the simplified version, using the distributive property, is what's inside. So I'm going to take away these things. What's inside is 4x's plus 6. 4x plus 6. Okay. So flip to the next page. And what I want you to do is I want you to practice using these algebra tiles to build each of these expressions. When you're done, you should have an expression that looks like our simplified version. There should be no parentheses, and for all of these, there should be just 2 terms. And I want to really caution you. I want you to notice my least favorite operation is hanging out here. You know what to do with it. We've also got negatives. Make sure you're representing those negatives correctly, thinking about all you did with integer multiplication. All right, good luck. When you're done, check with the control.